Good morning, everyone. My name is Sun Yubo, and I'm here on behalf of the minivision team to give a brief introduction of the methods we used in the VQA track of the VizWiz Challenge 2023. We are from the Artificial Intelligence Research Department at Minivision in Nanjing, China. Here are our team members and contact information. Please do not hesitate to reach out if you have any questions. Visual question answering is a task that requires the model to predict a suitable answer to a question about an image. The VizWiz VQA Dataset is designed to focus on the needs of blind people. It's a collection of spoken questions asked by blind or visually impaired people. These questions are often open-ended, and also the question may be unanswerable because the image suffers from poor focus and lightening, or is missing the content of interest. There are two datasets used in our method. The first one is the official VizWiz VQA dataset. The second one is the synthetic data, which is created using the dataset from the SOD track. We initially selected an image from the official SOD training dataset, as shown in this picture, and we then input the image into blip model along with the prompt, what is the salient object in this picture. Next, we took the original image, the corresponding mask from the SOD training dataset, and the caption we got from blip, and fed them into the stable diffusion model. We used its impending feature to create synthetic image data associated with food. Finally, we simply generate an image question pair, like this. This method of generating data greatly enriches the picture, but does not lead to more questions, as we only ask a single question, which is what is it in the picture, so the synthetic data is not very useful in our experiments. In this computation, we trained models based on blip2. blip2 is a model composed of three main components. They are an image encoder, a Q-former, and a large language model. The image encoder is a pre-trained image model that extracts features from images, and the large language model is responsible for generating text. The Q-former is a lightweight transformer encoder that pre-trained in two stages. In the first stage, the Q-former learns vision language representation from a frozen image encoder. In the second stage, the Q-former learns vision to language generation from a frozen large language model. In this challenge, we use the VIT model family as the image encoder and the flying T-file family as the large language model. We experimented with model fusion by combining the outputs of blip2 models, trained with different training strategies. We first trained the blip2 model with different training strategies. Each model is trained for 5 epochs. And then we got some conclusions. The first one is, considering the most popular answer as the ground truth is better than using the weighted answers. The second one is, there is not much difference between whether or not to set the question query as an input to the Q-former. The third one is, if resources are permitted, it's better to fine-tune the parameters of both Q-former and the image encoder, rather than only fine-tune the Q-former. The fourth one is, VITG outperforms VITL. And the last one is, Dino V2 VITL doesn't perform well, because it lacks a pre-trained Q-former weights, which bridge between Dino V2 VITL and T5. Based on the previous findings, we fine-tuned the model for more epochs, and then we experiment with model fusion, which gave us a 58.22 overall score on the VQA track. Thank you all for your kind attention and support. Have a nice day.